Hi guys, I hope you guys are fine. In this video we are going to look at the adjacency list representation of a directed weighted graph. As you guys remember, a directed weighted graph is a graph which has direction, as is the case on the slide right now. I have an arrow which goes from vertex number 0 to vertex number 4, and the reason we say it is weighted is because the edge carries a particular weight on it. Now look at this example graph. This is what we will be coding. I will be using the adjacency list representation, which makes use of the list container in STL. In essence, what we will be doing is we will be simply going ahead and making sure that this graph gets represented, and we will print it. There are a total of 4 vertices labeled 0, 1, 2, 3 in this graph. Let's go to the coding portion of it. My code file will be called as dwadl.cpp. As before, the code will be available in our GitHub repository. You can find the link in the description of this video. So I will include #include iostream. This is for essentially for scene and cout. I will also include the header file list. The list header file is used for the list container. Let's go down into the main function. I will go ahead and I would use a pair. Pair is now used because I would be going ahead and storing it as a pair of two vertices. I will be storing the destination vertex along with the weight here. I'm making it a dynamic array, hence star al. I will go ahead and write down new list pair integer and I would need to specify the number of vertices. The number of vertices are 4. If you go ahead and look at the graph, there are 4 vertices, 0, 1, 2, 3. I will go ahead and add the first edge. I will pass this add edge function the list representation, the adjacency list representation, along with the source vertex. Let's start from vertex number 0. So the source vertex becomes 0. The destination vertex is vertex 1 and the weight is 4. Let me just copy and paste it. Once again, from 0 there are 2 outgoing edges, one to vertex number 1, the second one to vertex number 3. So I would say 0, 3. The weight on this edge that goes from 0 to 3 is 5. So let me quickly put 5 here. There is no outgoing edge from vertex 0, but there are 2 edges from vertex 1 with the source as 1 and the destination as 2. The weight is 3. I'll go ahead and I would add another one from 1 to vertex number 3 with a weight of 2. Now these are the only 2 edges going out from vertex number 1. Let's look at vertex number 2. There is only one edge going from vertex 2 to vertex 3. So I will go ahead and mention the source vertex as 2, destination vertex as 3, and the weight as 6. Let's code out the add edge function. So void add edge. I will go ahead and hold the adjacency list representation here. The source vertex u, destination vertex v, weight w. Now how do we put it into this adjacency list? I would say ALU and push a pair. How do we make a pair? I'll use the make pair function. VW, they are to be used as a pair. What we're going to do next is I'm going to use the print graph function, to which I pass only one parameter, the adjacency list representation. So let's code out the print graph function. I receive what is sent to it here, star al, which is nothing but my adjacency list. I will run a loop for all vertices, 4 vertices, so 0 to less than 4. I will go ahead and I would be using an iterator here. So iterator, let me get the spelling right. It is ali.begin. So start from that till the time you don't have its end to an it plus plus. Print out the source vertex represented by I, the destination vertex, which can be had with the help of it, arrow operator first. This is how you get to the first in the pair, it arrow operator second, the second in the pair, and change the line. Let's quickly compile and run it. dwadl.cpp. Okay, compiling, got lucky there, no errors. A.out. So let's look at it. So it's saying there is an edge from 0 to 1 with a weight of 4. If I go back, this is the edge it is talking about. Let's look at the second one, 0 to 3 with a weight of 5. If I go back, 0 to 3 with a weight of 5. Okay, next one is 1 to 2 with a weight of 3, 1 to 2 with a weight of 3, 1 to 3 with a weight of 2. Okay, and 2 to 3 with a weight of 6. So this is how you represent the adjacency list representation of a weighted directed graph. This is how you print it. We'll find it useful when we are going to deal with this representation. It's a very efficient representation when we deal more with it in Dijkstra's algorithm, Bellman-Ford algorithms, so on and so forth. Thank you guys. Be safe. Goodbye.